Hi. Okay, so we're starting off again here with 1.1. This is the continued version of it, so kind of piggybacking off of what we started last time. If you recall, we were talking about graphing in the form of y equals ax squared plus bx plus c. Last time, we really only got to graphing things of like a smaller form. So today, we're going to really do things that have every single bit of that function. So the first thing we're going to start off with is graphing the function y equals 2x squared minus 8x plus 6. So again, this is a quadratic function because of the fact that it only has an exponent of 2. Okay, and that exponent has to be directly related to that x variable. If it was any larger or smaller, it would be a different kind of function, and we'd have to graph it differently. So if you recall, the first things we like to do when we graph or do any things with these kind of functions is we want to identify three things. Those three things are A, B, and C. Okay, you can directly correlate those with the function given below. So if we want A, B, C. A is always going to be that very first thing out in front with my squared. So we're down here, that's going to be this 2, because it's related to my 2x squared. So A here is going to equal 2. Same thing with B, it's always bx. I have a negative 8x. One really important thing to remember is that when we're dealing with these, you take the sign with it. So if it's a negative 8x, you're taking all of that negative 8. The sign matters. So it was a positive 2, so that brought it over a positive 2 for A. It's a negative 8. So this B is negative 8, okay? Last thing, my C is always the constant out in the end. It's got no variable attached to it. When we look here, my 6 has no variable attached to it. That is my C. My C equals 6. It was a positive 6, so my C is a positive 6. All right, why did I have to identify those things? If you remember, last time when we started graphing things, the first thing we wanted to use those for was finding the vertex, okay? This was step 1. Step 2, use those to find my vertex. If you don't remember, I can always start out by finding one specific part of my vertex first. That is the x-coordinate, and it is negative b over 2a. That's the formula I use in order to first start finding my vertex. Okay, so I'm going to reference the values I've already found and plug them in. So x equals negative. I have a negative 8 for b. I use all the negatives that I'm told I have to. So I have a negative, I put in a negative 8. This is over 2 times a, which is 2. Okay. One of the very first things we all should remember is that when you have a double negative, this is negative times a negative. That creates a positive. So this is going to be positive 8 over 2 times 2, which is 4. We want to simplify this fraction down because we know that 4 goes evenly into 8, and 8 can evenly be divided by 4. That is 2. So a vertex is a coordinate pair. In this coordinate pair, my x value alone is 2. That's not enough for me though, right? Like that's not my whole vertex. So I'm not done yet. I found the x coordinate of it. Congratulations, that part's done. We still need to find the y. The y is a much lengthier process of doing this because we have to take what we know and plug it back in, okay? If you have an x value and you want to find the y, you plug it back into your original equation. We look up here, and this is my original equation. So I want to show you that each and every one of these x's is going to get replaced with my x value of 2. I'm claiming my x value is 2, so I'm going to put that in there. So this is 2 times, instead of x, we write a 2. The squared stays though. Okay, this is substitution. Minus 8, instead of x, we put 2. And cannot forget that plus 6 there in the end. okay? Now it's our job to simplify this. Keep in order of your order of operations though, right? We go PEMDAS, right? Please excuse my dear Aunt Sally. So it's gonna go parentheses, exponents, and so on, right? So parentheses first, I don't truly have any parentheses, so I'm gonna start with my exponent. This is 2 times 2 squared, which is 4, okay? I can continue just leaving the rest of this as is, okay? So it goes, please excuse my dear Aunt Sally, parentheses, exponents, multiplication and division. I'm to that point now. So 2 times 4 is 8, minus 8 times 2, which is 16, plus 6. All right. Oops, you can't even see that. I'm sorry. So sorry. If we go and we add this all up, you should be coming up with a grand total. Okay. No, I got that right. Okay. Right. So we're coming down here and we should get -2. You can't really see my negative there very well. So sorry. Okay. So that means the y coordinate here is -2. As soon as I get a piece of information, I like to go put it on my graph. So I determined that my vertex is at 2, -2. Remember, we go over x and then to the y. So that means my vertex is over here, okay? So from there, I like to do one other thing. That is my y-intercept, okay? That's my third step here. To find my y-intercept, this one is a real nice and easy one. You truly use 0c, nothing else. So I put in my 0, my c value was 6. So that's a really quick, easy point for me. 0, 6. Over 0, up 6, that's right over there. So here now, I'm going to teach you guys a little trick. Oh, you can't really see my red dot. This little trick is something you would already know about parabolas. When we talk about a parabola, there's this dashed line straight down the middle, where basically if I folded that parabola along that dashed line, this parabola would fold up and it would match each other, right? These are symmetrical. So that line is always right over top of my vertex. If I put a dashed line right over top of my vertex, any point on this side mirrors to this side and vice versa. So if I found this one point, isn't it true that this point is exactly equidistant on the other side of my line? This point, if you count over, it is 2 x values away from my dashed line. So if I go 2 more this way, I have mirrored that point over. To me, these are the only 3 points I truly need to find. I could find more for sure, but I don't need to find more. So I'm going to call that my parabola. And I know that my a value is positive, so it's opening up. My a value is the absolute value of my a value is positive and greater than 1. So it's also being a little bit more narrow, okay, a little bit narrower and taller. That is all we need to do for that problem. So there's one more thing and then we're completely done. So there's times where we want to find the maximum point of a parabola and the minimum point. So you can only find one or the other because only one or the other exists. So when we're talking about a parabola that opens down and a parabola that opens up, I can only ever find a maximum or a minimum. Now, the reasoning behind that is when we look at these two things. This parabola that opens down is going to go down forever. Am I ever going to have like my lowest point? I mean, it's going to keep going to negative infinity. So there's never like an infinity in one. There's never going to be my most smallest point down here. Same thing with this parabola opening up. It opens up and it's going to continue up absolutely forever. So I'm never going to have my highest point. So this parabola will have a minimum, and this parabola will have a maximum, but never both, okay? So when a parabola opens up, it was because the A is positive, right? We talked about that before. When one opens down, it's because the A is negative. So you can use these two things in order to help you figure out when you're starting out whether you'll be able to find a maximum or minimum. Let's do this quick example. I want you to find the max or min of y equals 3x squared minus 18x plus 20. Okay, so very first, oh, you can't see any of that. There you go. So find the maximum or minimum, right? One or the other of the following quadratic function. So I want to identify my A value. A is always the first one out in front. So my A equals positive 3. If A is positive, two things happen. My parabola opens up, and I also know that I'm going to have a minimum point. So how I want to find my minimum point is how I actually find my vertex, right? The smallest point, the very, very, very tippy bottom, the very, very lowest bottom, or the tippy top is that middle point in my parabola. So this is actually the vertex. So how do I find the vertex? That's the same way I'm going to find my maximum or my minimum. Vertex equation is x equals negative b over 2a, right? So let's do this whole thing again. We know my a value. What's my b value? We have to look at that very middle part for that. That is negative 18. Okay, so x equals negative 18 over 2, 3. We know those two negatives are going to make a positive up top, so it's positive 18 over 2 times 3, which is 6. 18 divided by 6 is 3, okay? That's not all of it though, right? That was just my x value in my, what am I doing? I'm finding my minimum, right? This is the x value in my minimum. So that's 3. So when we have an x value and we want to find the y value, we have to plug it back in. So I'm going to use this space over here. If I plug my y or my x value back in, it's plugging into every single x in my original equation. I'm saying that my x value is 3. So this is 3 times, instead of x, I'm putting in 3 squared minus 18x. Instead of x, I put 3 plus 20. If you do all the math, and I want to keep this short, so I'm not going to do all of this math here, just like we did last time, you will get this down to be y equals negative 7. So that is a negative 7, meaning that this coordinate point is your minimum, okay? Usually we even kind of stress what's the minimum y value. So the minimum y value would be y equals negative 7. Okay, that's it for this video. Again, in-person learners wait to do the work until I see you in class. Remote learners, let me know if you have any questions. Thank you.